Today on Square Raindrop, we're talking to Don Griffith. Don has dedicated his whole working career to cloud seeding and weather modification, so I thought it would be really interesting to find out what he has to say on the subject. So welcome, Don.
Thank you very much.
It's great to have you join us because there's a lot on social media at the moment about cloud seeding and weather modification. I think part of it is in the UK, we don't really hear much about it, but we know in the US and other countries, it's quite well used and there's a lot more known. So I thought it would be really interesting for people today to hear from somebody that has dedicated just about their whole working life to cloud seeding and weather modification. So tell us a bit about what you used to do and how it used to work.
Okay, well, just a little background about cloud seeding. There's typically two types actually three maybe. There's two main ones that are being practiced in various parts of the world. One is seeding clouds to increase precipitation, rainfall or snowfall. And the other is to mitigate the damage from hailstorms by seeding them to reduce the size of hailstones. So when you think about it, those two applications apply where there's typically a shortage of precipitation or there's hail occurring. So in our country, that's typically, in terms of precipitation, west of the Mississippi River, where there's less precipitation than east of the Mississippi. And then hail suppression or hail mitigation is practiced in our country in North Dakota and next door Alberta in Canada. So, and hail suppression is practiced in various parts of the world like France and Spain and Argentina, where they have wine growing grapes that they're trying to protect from hail damage.
Ah, okay. So it's used to try to help crops, essentially.
Well, help crops in the sense of reducing the hail damage, but the main uses for enhancing precipitation are probably two or three. One, for drinking supplies, municipal water supplies. Two, for irrigated agriculture. And the third one is a little surprising, but when you think about it, it's not surprising. And that are river basins like in our country that have hydropower facilities installed. If you can increase the snowfall in the mountains that feed that hydroelectric plant, then you increase the power production.
For the rainfall increase, is that mostly done over mountains? Am I right in thinking that?
Well, yeah, there's a kind of a subdivision of precipitation enhancement, we call that. And it's in the wintertime, it is done over mountainous areas. And that's to increase snowfall, obviously, instead of rainfall. In the summertime, it's typically done over croplands like in Texas or Oklahoma or something like that.
But over Texas, I'm guessing in the summer, that's mostly going to be from thunderstorm clouds. So that's convective as opposed to sort of orographic enhancement.
Correct.
Okay. Because my understanding is it's easier to show that there's an increase in rain from orographic enhancement than it is from showers, because it's more difficult to show and prove distinctively that you've increased the shower, because showers are a little bit more hit and miss, aren't they?
They're smaller in size and duration. So to show you're increasing rainfall over an area, say a target area of 1,000 square miles, that's more difficult to do in the summertime, you're right. The wintertime, it's easier to show because you can look at stream flow from that drainage, for an example, and do statistical tests to demonstrate that you're increasing the stream flow.
And how often would you say that it's used? Over what period? Are we talking tens of years or, how many decades? And how often might it be used in a year, say?
Well, we're going into the history of how cloud seeding started, but some of the cloud seeding started here in our country in the early 1950s. And that was due to some discoveries by Vince Schaefer and Dr. Vonnegut working out of the GE laboratories in Schenectady, New York, where they basically discovered you could modify clouds either by dropping dry ice into them or using silver iodide as a seeding agent to modify them.
Okay, and so that was in the 50s. So it's been used on and off since the 50s. And how often would you say in the course of, say, a month or in a season that it would be used in the US typically?
The wintertime programs will typically run from, say, November to March or April, and you would seed each storm that you perceive to be, quote, seedable, as far as meeting some certain criteria. So you might have, in the wintertime, you might have 30, 40 storms that would be seeded during those months.
Okay, and how do you know if there was a lot of talk recently about the floods in Dubai? Now that was a very different thing, and the storm coming was really intense, and the weather models had it as in the forecast anyway, so that can't really have been cloud seeding. But how do you ensure you don't end up with some kind of flooding event?
Good question. Any well-designed cloud seeding program will have a good design for how the program operates. And that will include a variety of things. How are you going to seed the clouds from the ground or from the aircraft? What kind of seeding materials will you use? How will you dispense it? But then it'll also include what's called suspension criteria. So you will have pre-ordained situations where you will not start cloud seeding if you have any thought that there could be concerns about flooding.
Okay, okay. So they all sort of have a standard. If it goes out the standard, that's it, it's cancelled.
Right, you automatically would not even start seeding a storm if you see, like in our country, we have atmospheric rivers hitting the west coast of the United States. So if you see one of those coming into your target area, it's going to drop 8 or 9 inches of rain or snow or rainfall in the snow, you would not seed those.
Okay, okay. And how do you answer people who say there's only a finite amount of water in the atmosphere?
Okay.
So if you cloud seed and you generate more rain here, then downwind, is it necessarily the fact that they'll have less rain than they would have done anyway? Or
Okay,
does it
that's a
not work like
common question. That's called robbing Peter to pay Paul, typically in our industry. And so what you will be surprised to know is that of the atmospheric water that passes over, say, the United States, only about 10% of it will fall as precipitation. If you're getting a 10% increase from the cloud seeding, then you're only changing the water balance by 1%. So no, you're not going to rob Peter to pay Paul. In fact, I worked on a paper that's published in 2014 that pretty much identified that, surprisingly, instead of decreases downwind of those project areas, there are typically increases out to maybe 100 kilometers or so.
Okay, that's interesting. And if you are cloud seeding on a regular basis, as you presumably are, over a similar area in the west of the States, are there any detrimental effects to the silver iodide being thrown in the atmosphere?
That's the other common question. No. I can read you a statement from the Weather Modification Association. It's a nonprofit organization here in the United States that deals strictly with cloud seeding from the regulator side, from the operator side, and from the sponsored side. But here was the 2009 position statement from WMA, we call it. The published scientific literature clearly shows no environmentally harmful effects arising from cloud seeding with silver iodide aerosols have been observed, nor would they be expected to occur. Based on this work, the WMA finds that silver iodide is environmentally safe as it is currently being dispersed during cloud seeding programs. And there's a lot of other studies that kind of go into this statement. In fact, going back into the 1970s, even publications about the safety of silver iodide. One of the interesting things about silver iodide, it's very insoluble in water. So once you put silver iodide into clouds and create ice crystals that form snowflakes, say, and it falls to the ground, then it's not going to end up in the water supply because it's insoluble.
Okay, great. And so that's how cloud seeding works generally with silver iodide. What about hail, mitigating hail? Is that again silver iodide, or is that a different effect?
Typically, sometimes dry ice is used, but more commonly silver iodide.
Okay, so how does it work then? Explain to our listeners how that works.
Okay, the basic concept as far as cloud seeding is concerned is, well, let's talk about precipitation first. Something called the Bergeron-Findyson theory that was developed in the 1930s. Maybe you're a meteorologist, you're familiar with this, but
Yeah.
basically saying that most of the precipitation over continental areas is produced by supercooled cloud droplets in clouds that do not freeze, and that you can inject something, foreign particle that's needed to convert a water droplet, cloud water droplet, into an ice crystal that can grow into a snowflake and fall. So what they discovered is naturally that happens. The impurities are basically dust or some kinds of bacteria. So what Schaefer and Bonnet discovered was that silver iodide's crystalline structure was very similar to that of ice crystals. So the water droplets in the clouds that were unfrozen would freeze on silver iodide very rapidly at temperatures below about -5 to -7 centigrade. You might be surprised to hear, and well, being a meteorologist, I guess you won't be, but in very pure water in a laboratory, you can lower its temperature to -40 centigrade before it will freeze spontaneously.
Great. So that's how to seed clouds. What about mitigation of hail? How does that work for that?
Well, it's more, there are several theories how this might work, but it's one of the theories is by seeding the cumulus clouds that are going into say, a thunderstorm, you'll develop a lot of ice crystals in that feeder cloud that will then spread the amount of liquid water in the cloud over more hailstones. So you'll reduce the size of the stone because they're competing for the available water in the cloud.
Okay, a little bit like then how you might try and deplete fog in a similar method.
Okay. That's something you can do in only in supercooled fog. You can't do anything with warm fog, so it has to be below freezing. So you can, it's been done here, like in Salt Lake City in the past, dropping dry ice pellets into the fog bank that's approaching the airport, and the dry ice will freeze the water droplets and create a clearing.
Okay.
You can also do it with compressed carbon dioxide, for example.
Okay. Okay. So is there anything else we can use cloud seeding for? I know that some people are saying it might help against the fight with climate change, sort of in a similar way to solar dimming, that sort of thing. Is there anything that could be done there?
Yeah, I think you need to draw a distinction between current day cloud seeding, which is kind of a small impact if you think about it over scales of time and space, a few hours and maybe a few hundred square miles. But when you're talking about trying to modify the climate to combat global warming, then that's a term that's usually referred to as geoengineering. So that's a much larger scale. There are some theories out there about if we put certain salt particles, for example, in the upper atmosphere, they may absorb water and create a kind of a shield for the sunlight reaching the ground. So that's a fairly contentious debate about once we do something on that scale, is it something irreversible?
Mm.
So is it worth the chance of doing something to reduce global warming that might have a different effect than we might expect?
Yeah. Do you think there are experiments currently taking place to see if it's possible or if it's feasible?
I don't think anybody's tried it in the atmosphere. I think you'll see, if you read the literature, quite a bit of theories of how it might be done, but I'm not aware of anyone who's probably brave enough to try that.
So obviously we've spent a lot of time talking about what happens in the US with the US modification. And you mentioned that in Argentina and Spain and France, they also use it. And I know from my time, I used to live in the Middle East. So in the UAE, they use it. And I know that they use it in China and they've tried it in Australia. It didn't work quite so well for them. Do you know if they've used it in the UK at all?
I don't believe so. And if you think about it, I think the reasons are fairly obvious. One, you get a lot of rainfall. You don't need more typically.
I would
Nor,
agree with you. It's been incredibly wet this year. It's been awful. Don't visit us.
there you go. Nor do you experience any hail, or very infrequently if you do at all.
Not big hail. No, we don't get
No,
hail like you
not
guys
damaged
do.
hail. So I think that's the answer, that it wouldn't probably be conceivable in the UK, much like it's not very conceivable here in the United States east of the Mississippi, like I mentioned earlier.
Yeah. Is it expensive then?
It depends how you want to look at that. It can be relatively expensive, but well, first of all, you might be interested to know that the American Society of Civil Engineers have put out publications on augmenting precipitation and hail mitigation. And in that, one of those publications, it talks about looking at calculated benefit to cost ratios. So the recommendation is you design a program to see if you can convince yourself if you increase precipitation by this much, it's going to create this amount of benefit, and you express that in dollars, and then you divide that by the cost of the program. And if the benefit to cost ratio is more than 5 to 1, then you're the sponsors of the winner, if you look at it that way. So it might be $100,000, $200,000 to run a big wintertime seeding program, but you might get $1 billion of benefits, say, from hydropower production.
Brilliant. It's good that it's so tightly regulated, because that kind of brings it a bit more confidence. Is cloud seeding something that is more commonly known about in the US than the UK? In the UK, because we don't really have it, nobody really speaks about it. And then it becomes a kind of conspiracy theory that they're doing it secretly. In the US, is it more open?
It is. It's more publicized here because you'll have some project will get somebody's eye, and there'll be a local news reporter like yourself that will start interviewing the sponsor or the operator of the program, and then that'll hit the news, so it gets spread around through the news cycle. So it's pretty well known here in the States. The other thing that you might be interested to know is when you're designing a program, what the recommendation is that you would do a feasibility study first. So you would take known results from other target areas to go into a new area and try to assess if you believe you can increase the precipitation and how you would do it and how much you could do it. Talk about suspension criteria and so forth. So the feasibility study would precede the development of a project design.
Okay. And just finally, when you look back at your career, which has been, amazing, really, you've been forefront of the technology, but what would you say you're most proud of?
Well, it's not just one example, I guess. It's just a feeling that the work I had done and others like me have done in developing this field to help it to grow has resulted in benefits in multiple areas where I've worked, like in the US and other foreign countries.
Brilliant. Well, thank you so much for joining us today, Don. It's been fascinating talking to you. And if our listeners and viewers have any comments, would it be okay if we sent you a few questions?
Of course.
Brilliant. It's been so good talking to you. Thanks so much.
Good to meet you.